Okie dokie, so here we are on your problem 6. You can see I've already labeled the streets as described, April being X, Division being Y, Embarkment being W, and Broadway being Z. So now let's write our equations, because I noticed that's where we had a couple problems. So first things first, the first equation you had was right, X plus Z equals 300, because the amount of traffic, 300, some of it's going to have to flow down there, some of it's going to have to flow down there, but all 300 cars have to make up X and Z. So we put those together, we get 300. So using a similar logic, there's no particular order in which you need to write this. I'm just going to go down here to, let's say, embarkment, okay? How do cars get onto embarkment? Well, they either have to come from Broadway or they have to come from Canal. So therefore, W is equal to 100 plus the amount of cars coming from Broadway. Okay, there's that path. Now, let's see if we can write an equation for Y. How do cars get onto Y? Well, it's the number of cars coming from April, because the only way they can get there is coming around here. But they're going to lose 100 cars. So it's the amount of cars on April minus 100. So there's that equation. Now, we also can say, I know, for example, I know we got this 300 here, so let's make an equation for that. We know Y and W, when we put those together, those have to equal 300. Now, this technically should be enough equations. We have 4 equations, 4 variables, but let's see if there's anything else. Take a quick second, just verify we didn't miss anything. As of right now, I'm not seeing anything. Let me go back and read the directions real quick. That is all I see. There's no other information in the what's the word I'm looking for? In the directions. So now we're just going to run with it. We're going to say, okay, to solve this system, we have to write it in matrix form. So we'll kind of rearrange some of the equations. So like this one, we need to get the constant on the right, the variables on the left, so on and so forth. So I'm just going to rewrite them all in here. So I'd have X plus Z equals 300. When I subtract the Z from both sides, that would give me W minus Z equals 100. Then I'd be left with down here. The next one right here would be, again, getting 100 by itself. So Y minus X equals negative 100. And then last but not least, that one's already in the right form. Okay, so now to actually put it into our matrix, we have to put some kind of order. So maybe we'll do X. Oh, and actually, the problem does say it wants it in terms of W. So we want to make sure that W is last. So just in case it doesn't work out nicely where we have an exact number of solutions, it'll be in terms of W. Okay, so we're going to do it in this order. So the first equation would be 1x, 0y's, 1z, 0w's equals 300. Okay, the next equation, we have 1w, negative 1z's, 0 of everything else, and then 100. That's what that's equal to. Now, the next equation, 0x's, 1y. Oh, sorry, I lied. We did have an x. We have negative 1x. Wait. There we go. Negative 1x, 1y, no z's, no w's, and that's equal to a negative 100. Then last but not least, 0x's, 1y, 0z's, 1w, that's equal to 300. So we're going to pop that in our calculator and see what we get. Okay, so now with the calculator, if you actually need to watch this, watch it. If you don't, just fast forward. But here, I'm going to bring up the matrix. Whoops, that's not what I wanted. I want to bring up the matrix. We're going to edit our matrix. It's going to be a 4 by 5 because there's 4 rows, 5 columns, and we start typing 1, 0, 1, 0. The last column, 300. Okay, then we're going to have 0, 0, negative 1, 1, 100. Okay, then we have negative 1, 1, 0, 0, negative 100. I just realized part of this may be off the screen. I apologize for that. Let me see if I can scoot this down a little bit more. Maybe that makes it a little easier. Okay, then the last row, 0, 1, 0, 1, 300. 300. Now, I always recommend double check. Make sure you get everything in right. 300, 100, negative 100, 300, 0, 1, 0, 1, 1, negative 1. Perfect. Okay, arrow over. Check these. Okay, looks good. So now we're going to do, we want to do reduce our echelon form. So we're going to take this out to here. Reduce our echelon form of our matrix A. And we get this. So what do we notice? The bottom row, 0, 0, 0, 0. All the equations still have a W in them. So this means to me we have infinitely many solutions. So it's time to write down our answer. Okay, so I just rearranged the screen a little bit so you can see both things at the same time. So now, the first equation is read as x plus w equals 400. Then I have y plus w equals 300, and then last but not least, z minus w equals negative 100. So now, to write these in terms of w, it means I'm going to solve for x, solve for y, solve for z. So the first equation here would just become x equals 400 minus w. The next equation would be y equals 300 minus w. That's the worst w ever. Try again. There we go. And then last but not least, z equals negative 100 plus w. So how I'm going to write this now all in my answers, in my ordered quadruplet, since I have 4 different variables. Instead of writing x, I'm going to write 400 minus w. Instead of writing y, I'll write 300 minus w. And so on and so forth. Whoops, my pen just went a little crazy there. What happened? Let's try again. Negative 100 plus w. And then last but not least, so this is my x, y, z. So last but not least, what do I write for w? Well, I just write w because it's arbitrary. What I'm saying is pick any value for w, and I'll tell you the rest. So when we go back and look at our original picture, what I'm saying, I will tell you how many cars need to drive down an embankment, and then you give me that information. We put a little speed strip down there or whatever, and a little counter, and we'll count how many cars drive down it. And then I can tell you how many went down Broadway, April, and Division by just using these simple little equations. Okay, I hope that made sense. Hope that helped. Best of luck.